Alpha beta pruning. Okay, so pruning means to reduce something by removing parts that are not necessary or wanted. So, for example, in a tree, um, we're going to cut branches that are not necessary or not necessary or wanted. Okay, so alpha beta pruning is about improving the minimax algorithm so that we don't have to examine or explore all nodes to get the minimax value of a game tree. Hey, just like the minimax algorithm, our goal is for max to have its best value and for min to have its best value. So in a game tree, in this game tree, for example, A is the maximum of these three nodes, and these nodes are the minimum of things below them. Okay, so first, we're going to get the maximum of the minimum of these three. Okay, and the minimum of this 3, 12, 8 is 3. The minimum of this 2x, y is the minimum of 14, 5, and 2 is 2. So by intuition, we will know that the maximum will be 3. But why is it that we're sure that 3 will be the maximum if there is z, which is its value is 2x and y, the minimum of 2x and y. We don't know what x and y, but we're sure that whatever the value of x and y, it will not affect the minimax value is 3 because z is less than or equals to 2. So kahit mas malaking number or mas maliit na number, hindi siya makaka-apekto kasi yung 2 is less than na sa 3. Okay? So, alpha. Alpha is the value of the best choice we have found so far at any choice point along the path for max. And beta, the value of the best choice we have found so far at any choice point along the path for min. So, alpha is for max and beta is for min. Okay, so here alpha, the value of alpha is negative infinity and the value of beta is positive infinity. Okay, min would want something less than beta but is greater than alpha, and that way we can get the smallest possible beta that is also better than alpha. So alpha is max's best value, and we want alpha to be greater than any previous alpha, but also lesser than beta. So because beta would want the best mean value, while alpha, of course, would want the max's best value. Because of that, they'll end up both not getting what they want because they are opposing each other. So an example for this is this game. Okay. So we're going to start from the root and then b, and since it's depth first, we're going to start from 3. Okay. Is 3 less than alpha? No. Because, yeah, alpha is negative infinity. So, and we're going to ask if 3 is less than beta. Yes, so now the value of beta is 3. Okay, we're going to check if the other two leaf nodes is less than alpha and less than beta. Okay, so 12 is not less than beta and not less than alpha. So we're going to 8. 8 is not less than beta and not less than alpha. So the mean value of this node, if these nodes is 3. Okay. So is 3 less than is greater than alpha? Yes, it is greater than. So 3 is now a candidate for the minimax value. We're now going to update alpha to 3. Okay, next we're going to see. Okay, first value is 2. Is 2 less than alpha? Yes. But remember, mean wants to keep beta small but bigger value than alpha. Why is that? Because it ensures that max will gonna pick that value. Return 2 because we know that it may be beta or less than beta, but it won't be greater than alpha, so there's no point in exploring those nodes in this subtree. So yun. Less than siya kay beta, but hindi siya, pero mas malaki pa rin yung alpha. So, kahit na mas maliit siya kay beta, hindi pa rin siya magiging candidate sa minimax kasi nga, mas maliit siya sa 3. So, yung best ano pa rin ng alpha ay 3. So, punta naman tayo sa D. Okay, D. First value ay 14. Is 14 less than alpha? No. So, it won't go up, just like 2. Okay, same as 5. They are both a great candidate for alpha, but they are not less than beta, so okay. 2. Is 2 less than alpha? Yes. So we're going to return it as the mean value of t. Since it is less than alpha, but not greater than beta, 3 is our minimax value because we're going to get the maximum in 3 to a 2. So yung maximum niya ay 3. So, dahil sa alpha-beta pruning, nakapag-save tayo ng time. May dalawang tayong hindi na pinuntahan kasi alam na naman natin na kahit anong maging value nitong dalawa, dahil sa value nitong una, hindi na siya, parang avoid na siya ng A. ng root. Okay, so kung nagkataon na 2 ito, tapos ito 5, or 14 to, ganyan. Makita pa lang yung 2, kahit hindi napuntahan tong dalawang node na to. Kasi alam na natin na yung 2 na yung minimum, or kung may minimum man dito, hindi naman siya mas malaki sa 3, kaya baliwala lang din. Okay, so yun. Yung pag-arrange din ng value, kung nakasort to, mas madali yung pagpaprocess ng pagkuha ng minimax value. So, okay, yung minimax value natin ay 3.